So we've been looking at some probability and the likelihood of events occurring, and so there's some different types of events that we need to look at in light of that. Specifically, we're going to look at mutually exclusive and non-mutually exclusive events. So mutually exclusive events are different events that cannot occur simultaneously. And I usually just remember because of exclusive. Exclusive means that something's kind of special, so it's limited, and so they're limited to happening by themselves. So examples of this: a coin can either be heads or tails. You can't have heads and tails occur at the same time. If you roll a die, you're going to get even or odd. You can't get both even and odd at the same time. So if we look at this using a visual, so we got a bag containing 6 red, 3 blue, 5 green, and 2 yellow marbles. What's the probability of drawing a blue or a green marble? So here's our box, our sample space that fits everything. We have our blue outcome, and so there are 3 blue. There's 3 blue that can fit in there. So 3 outcomes are going to be blue. Our green outcomes, there is going to be 5 possibilities there. And then our total sample space, that needs to have the rest of the marbles. So there's 6 red and 2 yellow left over for a total of 8. So there's 8 items left in that sample space. So the sample space has 8 plus 3 plus 5, and that's our total marbles. 8 plus 3 plus 5 is our total possible, or our full sample space. So if we want to find out, and I'm going to show you 2 methods here, the probability of pulling a blue or a green marble. The probability of blue or green could be written like this in the parentheses. And so we look at the probability of blue or green. So blue or green means we need to get these total probabilities. So there's 3 and 5. 3 plus 5 over our total sample space, which in this case is going to be 16. So 16 is our total sample space. So 3 over 5, or 3 plus 5 is 8 over 16, or 1/2, or 0.5. So we got a 0.5 chance of drawing a blue or a green marble. Now the other way to do it is you can look at the probability of B plus the probability of G. So the probability of pulling a blue plus the probability of pulling a green. So the probability of pulling a blue is 3 and 16. The probability of pulling just a green is 5 and 16. Adding our fractions, we have 8 over 16, which again is 1/2, which again is 0.5 as the decimal. So 2 methods. We often write things like this though because it's a little cleaner, and it'll work out a little better when we look at some other possibilities, such as non-mutually exclusive events. So non-mutually exclusive events are events that can't occur, that can occur at the same time. So if you were drawing cards from a deck and you're looking at drawing a diamond or an ace, you could draw an ace of diamonds. And in that case, you've satisfied both that you've drawn a diamond and you've drawn an ace. So non-mutually exclusive events are ones that can occur at the same time. So another example could be rolling a die. What's the probability of rolling a 2 or an even number? Well, if you roll a 2, you've also rolled an even number, so it's a non-mutually exclusive event. So we got an example here. A provincial park has 220 campsites. A total of 80 sites have electricity. Of the 52 sites on the Lakeshore, 22 of them have electricity. What is the probability of a randomly selected site will be on the Lakeshore or have electricity? So we're going to have be on the Lakeshore, or we're going to have electricity. So if we look at our events here, we have the Lakeshore events and then the electricity events. And we have an overlap because some of those Lakeshore sites have electricity. And so we're going to start there in the middle where we actually have 22 sites are on the Lakeshore and they have electricity. 52 sites are on the Lakeshore. So there's 22 already. It's in that circle. So what remains is 52 minus 22. So there's 30 remaining sites that are just on the lakeshore that don't have electricity. Sites that have electricity, there's 80 sites that have electricity, and we already have 22 taken into consideration here in the circle. So the remaining sites that don't have electricity is 80 minus 22. That's 58 sites. Now, our entire sample space out here are the sites that don't have electricity and are not on the lakeshore. So there was 220 sites in total. So 220 minus 30 minus 22 minus 58 is going to give us, there's 110 sites that are not on the lakeshore and do not have electricity. So there's a visual of that. Now, when we're working with a probability of one or the other happening, we'll take a look here. The probability of lakeshore or electricity is equal to, well, the probability of being on the lakeshore is 30. And we're going to do over 210, or sorry, 220. Sorry, I'm messing that up. Let me show you the longer way, or the better way with this, that doesn't use the diagram. So if we ignore the diagram for a minute, we have 52 sites on the lakeshore. So 52 out of 220. Plus, there are 80 sites with electricity out of 220. So there's the probability of being on the lakeshore. There's the probability of having electricity. Now, because there is that overlap, right? There's 22 sites that have they're on the lakeshore and have electricity. We're counting those twice. So we got to get rid of that probability. So minus 22 out of 222 or 220. So the probability of being on the lakeshore, the probability of having electricity minus the overlap. That will give us a probability of being on the lakeshore or having electricity. And when we calculate that out, we have 52 plus 80 minus 22. So 52 plus or minus 22 is going to give me 30. 30 plus 80 is going to give me 110. So 110 out of 220, and that's going to give me 1/2 or 0.5%. So we have a 0.5% chance of being on the lakeshore or having electricity. So because, and if we look at the diagram, we had a 30, there was 52 on the lakeshore, and there was 80 on that had electricity. That 22 is overlapped. So here we're counting it twice if we just add the probability of the lakeshore and the probability of the electricity. So we have to get rid of one set of that 22 so we don't count it twice. And so that's what happened here, 110 out of 122. This happened to be half the campsites. That these numbers won't always match. It just happened in this case that the numbers matched. So formulaically, the probability of A or B is the probability of A plus the probability of B minus the overlap. So technically, this actually works with our mutually exclusive events as well. So here we've seen the probability of B or G is same as the probability of B plus G. So that's what we have here in this first bit. Now we're just factoring in the fact that we're removing those overlap. Now, in some cases, depending on which worksheets, what websites or textbooks or whatnot that you're working with, you might see that the probability of A or B is written as the probability of A union B. And you might see that the probability of A and B, that part we were overlapping here, so that's A and B, or in this case, L and D, it's written as the probability of A intersect B. And it's written like that. So this is another possibility that you might see if you're looking things up in terms of probability. But the most important thing here is just understanding if the events are exclusive or mutually exclusive. So this is our formula. If it's exclusive, then there won't be any interlap. But if it is not mutually exclusive, then that means that the events could happen simultaneously, and you have to take in consideration what you'll be taking away.